Hi everybody, welcome back to the channel. In this video we're going to take a look at some examples using antiderivatives. I want to just point out one thing that I probably should have mentioned in the last video that I either forgot or didn't have time to mention. When we talk about an antiderivative, you might remember from a past lesson that when you talk about derivatives being equal to each other, like let's say f prime of x is equal to g prime of x. And the question is, do f and g necessarily have to be the same function? And you might remember that no, they don't. That f of x is not necessarily equal to g of x. They could be off by a constant. And so let me put it like this. F of x has to be equal to g of x plus some constant c, because when you think about taking the derivative of both sides here, the derivative of f gives you f prime, the derivative over here gives you still just g prime, even if there's this c on here. So when we talk about finding a general antiderivative, we actually need to include the fact that there could be some constant on the end. And so what you'll see is that we don't just talk about function of f, we talk about a function of f that includes a plus c on the end, because it could be off by just a little bit. So let's take a look at some examples. Let's say that we have a function that starts like this, and I'm going to call it f of x. In the last video we would have called it f prime, but think about this function is a derivative. And what we want to find is the antiderivative, or kind of working backwards. So this one should be fairly straightforward to start out with. And this is just to kind of illustrate that point of adding a plus c on the end. Okay, this is a power rule kind of an idea here, as we're trying to undo that. So if we were to try to find the most general antiderivative of this, I'm going to go ahead and call it capital letter f of x. That'll make a little bit more sense in a few sections when we're using capital letter f and lowercase letter f. And so one way you can think about little letter f here is that this is capital letter F prime. It's the derivative. And so f of x, capital letter F of x here, I'm going to just kind of walk through the same steps we did in the last video as far as undoing a product or undoing a power rule. And so if you think about this as being an x to a power, in the original function there needed to be an x to the third in order to take the derivative and get an x squared. And then you need a fraction out front that's going to cancel that exponent dropping down. Okay, same thing in the next part. I'm going to leave the minus 3 out front. We're supposed to have an x to the second power up there because you got to go up by a power of 1. But then I need a fraction out front that's going to undo that exponent dropping down. Now, how do you handle a constant like this, like a plus 2 on the end? What's the antiderivative of something like that? Okay, do you remember that when you take the derivative of something like 2x, you just get a constant? So it's still actually a power rule. If you think about this as an x to the 0 power, you're adding a power of 1 and you're getting an x to the first power in there. Okay, and so let's see, do we need to simplify this at all? That'd be a good idea. And 1/3 x to the third, and then minus 3 halves x squared plus 2x. And then don't forget that what we just talked about is that there also could have been a constant there on the original, and so I'm going to put plus c. In fact, I probably should have put it up here at this step, but plus c there to say that we need to account for the fact that the derivative of the constant on the end would have been like having a plus 0 up there in the derivative function. Okay, so let's go ahead and take a look at a couple that are a little bit more complicated. Now that we've seen a few examples between last video and this video, we'll kind of mix it up a little bit and kind of throw in kind of a combination of some different ideas. So how about something like this? Our original function little f of x is going to be 3 times the square root of x minus 2 times the third root of x plus 4e to the x. Okay, so the question is, that, remember, this is kind of like thinking about capital letter F prime, and so we want to know what is capital letter F of x, what is the antiderivative, or the most general antiderivative of this thing. Okay, so my suggestion to you with antiderivatives is actually the same suggestion I had with derivatives when you have roots. I think what would be helpful is to instead write this as 3x to the 1/2 minus 2x to the 1/3 plus 4e to the x. Haven't taken an antiderivative yet, just trying to simplify first. And then we can take the antiderivative and figure out what we get for capital letter f of x. Now we can undo some power rules here, and then we have this e to the x on the end, which is a good friend of ours. Okay, so I'm going to leave the 3 in front. This is going to become an x to the 3/2 power, and then I need a fraction down in front that's going to cancel out the exponent. Okay, hopefully we're getting some practice with this, and you're getting a little bit more comfortable with this. I'm going to leave the -2 out front. Let's see, this should be x to the 4/3 because I'm adding a power of 1, and then I need a fraction down in front that's going to cancel that 4/3 dropping down. Now, e to the x is our friend. We just leave the coefficient out in front, and then we say take the antiderivative of e to the x. But oh yeah, that's just e to the x as well, which is great. And now we can, and then we also need to include a plus c on the end, because if we could have had a constant on there where the derivative of that constant is 0 in our original, or in our derivative function there. And now we should think about trying to simplify anything in here with our coefficients. We have a 3 on top, 3 on bottom. We end up getting a 2x to the 3/2. Let's see, we have a 2 on top and a 4 on the bottom that can cancel. We end up getting a minus 3/2 x to the 4/3 plus 4e to the x plus c. Okay. Okay, a couple of things to include about this. By the way, some of you are thinking, well, what if it's a negative instead of a positive c? Couldn't you have minus c? Well, if c is a negative value, then you're just subtracting on the end. And the other thing with this is you could always check your work by taking the derivative of your final answer and saying, did I get what I started with? Okay, so if you take the derivative of this, hopefully you should get exactly the derivative function that you started with. All right, let's take a look at another example. So again, I'm going to call this capital F prime of x, which could just show up as little letter f. And this is going to look something like this. 2 over x plus the sine of x minus a secant squared of x. Okay, so the question is, can we find capital letter F? That's the antiderivative of little letter f. Okay, again, the most general antiderivative. There is probably a good way for you to think about 2 over x, and it's probably better to write it like this: 2 times 1 over x. Not necessarily to write it as x to the negative first power, because that'll make you think about a power rule. Did you think about this as a power rule, by the way? It's not. It's actually a natural log. Okay, so what we get when we take the antiderivative is 2 times the antiderivative of 1 over x is the natural log, but remember from the last video, it's not just the natural log of x, it's the natural log of the absolute value of x. We need that every time. Okay? And then, all right, what's the antiderivative of a sine of x? We said that this can be tricky thinking about trig functions. It's always good to just double check your work. This is actually a minus cosine of x. And you can double check that. If you think about the derivative of a minus cosine of x, it should be a minus sine of x, but that's the plus sine of x that we had above. And then, do you remember what the antiderivative of a secant squared is? That should look like a tangent of x. So remember that when we take the derivative of a tangent of x, you should get a secant squared. And then don't forget plus c on the end. Okay, there's really not much to simplify here. We can just leave it as 2 times the natural log of x minus the cosine of x minus the tangent of x plus c. But again, if you're not sure if this is what you want to end up with, consider taking the derivative of your final answer, and hopefully you should get exactly what you started with at the beginning. All right, so let's go ahead and take a look at another example. Let's say that we have something that looks like f prime of x, and I guess this is kind of like using capital F prime of x. We got to get used to a couple of different notations here. And what we're going to have on this one is actually what we're going to call an initial condition. And so an initial condition says we actually know a value of x and y in our original function. So let's say we have something like this: 5x to the 4th minus 3x squared plus 4. And what we know is that f of -1 is equal to 2. f of negative 1 is equal to 2. So let's go ahead and treat this just like we would before. Find f of x in general. Find the antiderivative. Let's walk through the same steps we had earlier. Keep the 5 out front. Should be an x to the 5th power because we're going up the ladder. And then we need a fraction out front that's going to cancel out that 5 that drops down. And then we're going to leave the minus 3 out front. We need an x to the 3rd power to add, we're adding an exponent of 1. And then we need a fraction out in front that's going to cancel out that 3 dropping down. Don't forget how to handle the constant in the original. That's going to look like plus 4x and then plus c. So you might ask, well, what is this f of negative 1 equals 2 doing? Well, what that's actually going to do for us is say that we can go and find exactly what c is. C is some constant, and in this problem, we don't need to necessarily guess or just have a plus c on there. We know that when you plug in negative 1 for x, you should get 2 as your output. So use the initial condition that we have there, and we know that when f of x is 2, we can plug in, and by the way, the 5 and the negative and the 1/5 out front will cancel, and you can take this negative 1 here and plug in everywhere you have an x. So negative 1 to the 5th, the 3 and the 1/3 are going to cancel. That's kind of nice. So minus negative 1 to the 3rd plus 4 times negative 1 plus c, and we can go find out exactly what c is. Negative 1 to the 5th is negative 1. So then minus, and then negative 1 to the 3rd is a minus 1. So that's kind of nice because we have a negative 1 plus 1. Those will cancel. And then we have a minus 4 plus c equals 2. So go ahead and add 4 to both sides. That means that c has got to be equal to 6. And so instead of just writing a plus c on the end, I'm going to go ahead and erase that over here. Now that we know what c is because of using our initial condition, I can just say plus 6 on the end. And this was the original f of x function. This isn't necessarily called the general antiderivative. The general antiderivative uses a plus c just in your final answer, whereas this one is a specific antiderivative using the fact that we have an initial condition to find out exactly what c is. Okay, these are a few examples. I hope you've enjoyed, and it would be a really good idea for you to go get a lot of practice using antiderivatives on your own.